Hey guys, how's it going? We're going to go ahead and look at the Quadfun test review. We'll go to start with number 1, and we'll try to get through this pretty quickly. Number 1 says, what are the attributes of the linear parent function of a quadratic equation, and what is the equation of the parent function of a quadratic equation? Okay, so first, the parent function. The equation is y equals x squared. Okay, one thing that we can say is definitely we can go ahead and start with our vertex, which is usually our most important point. We're going to say that vertex is at 0, 0. Axis of symmetry, the thing that cuts the parabola in half, is going to be that line right there. We can write it two ways. I'm going to go ahead and do AOS for short, axis of symmetry. And that is the line x equals 0, or we can also write it as the y-axis. We can do domain and range. Domain is going to be all real numbers, written as the double little line with the R. Range, it's going to be all numbers bigger than 0. We write that as y greater than or equal to 0. And I think that's it. I can't think of anything else that I'm leaving out. I mean, if they ask you about symmetric pairs or something like that, you can just go into y equals, type it in, x squared, and it lists out all your points, and you can see all your symmetric pairs. Okay. Number 2, write the domain and range of the following functions in words and using the correct mathematical notation. I'll go ahead and write it just using the correct mathematical notation. I'll speak the words, but again, this is just to finish a little bit quicker. Alright, so number 2, writing the domain and range. Alright, domain, even though this doesn't show it, these lines would go on forever even though they don't have arrows. If it doesn't have a point like these, then they go on forever. Right, so this one goes on forever. Domain of the function, if it goes on forever, is going to be all reals. Range, we measure that up and down. I have a maximum value in this case at 4. Everything else happens underneath the line. All the rest of my points happen down there. So my range is my y values. I always write it as y, 4, and then all of my y values are smaller than 4, so I write it as less than or equal to 4. Okay, with the next one, same thing. I don't have the arrows, but I can assume that these go on forever since they don't have a stopping point. So that goes on forever. Once again, we write domain and range. Domain, if it goes on forever, your domain is going to be all real numbers. Range, again, we look at either our maximum or minimum. In this case, we have a minimum right there. The lowest value that it gets to is going to be 1. So once again, I have y. I write the minimum or maximum value. And in this case, all of my y values happen up here, right? That's where my graph occurs above that line. So my y values are all bigger than or equal to 1. Okay, with this one, finally, we have one where we have to actually go in and we have to measure. And so we'll go through and we'll do that. Domain and range. What happens with domain and range if we have a finite, which means that it starts somewhere and it stops somewhere? How do we write those equations? All right, so with domain, I always tell my students, think about your domain, which is your x values, which we're going to use our x-axis. I always tell them, imagine that this is a ruler. And all we're going to do is measure where this graph starts on the left and where it ends on the right. So if I was measuring this with my ruler, I would say, hey, that's where it starts. I would bring that up to my ruler, and that starting value would be -3. I would follow this all the way to the left, see where it ends. It ends at 1. So I'm going to leave a little bit of space, and I'm going to write the 1. We're talking about domain, which is my x values. I'm going to write x in the middle. Your inequalities always point to the left. And then we look at which ones we can equal. Down here for the -3, we have a shaded circle. Shaded circles are going to be less than or equal to's. And this one, even though we can't really see it very clearly, that's going to be an open circle. An open circle are just simply less than. Okay, so I can equal the -3, but I cannot equal the 1. So my domain is -3 less than or equal to x less than 1. which again, the way that, or what this actually means is just means that my equation occurs between -3 and 1. That's all it basically means. With my range, we do the exact same thing, except this time we use our y value as our ruler. So now my y value is my ruler. Okay, because range is my y values. We do the exact same thing. This time we go bottom to top. So the bottom, the lowest point that this graph gets to, in this case, is going to be 5, -5. Leave a little bit of space just like before. And then the top of the graph. This is the thing that throws off students. A lot of students want to go here because they say that's where it ends, but that's not what we're looking for. We're not looking for when it ends. We're looking for the highest point that it reaches, just like in a roller coaster. So this roller coaster goes up. It reaches the maximum point right before it drops. It reaches the maximum at this point right here, which is 4. So skip a little bit of space, right 4. Range is my y value, so I'm going to write y, and then same thing, always do less thans. Just like before, which values can I equal? I can equal the value down at the bottom, because once again it's in closed circle. I can also equal the value up top because there's not an open circle there. There's an open circle on the 3, but since it didn't stop at the 3, or the highest point wasn't the 3, it was actually the 4, then we're going to leave it at the 4, so it's also less than or equal to 4. Alright, we can keep going. Number 3, it says answer the following true or false questions using the table at the right. It shows some of the points from a quadratic function. Alright, so with something like this, what I would do first before I answer any of these questions is I would go through and write out my symmetric pairs. So symmetric pairs, I always do this, I always circle them, and then I always connect them with, I call these the rainbows, but the rainbows you have to understand are connecting our symmetric pairs. 4 with 4. And then this, I already know is going to be a question, so I'm going to go ahead and write this in now. Even though we don't see a 6, that doesn't mean that there's not a 6 on my table. There is a 6 on my table, we just can't see it, so we're going to go in and write it in ourselves. So I'm going to go ahead and connect this to where I know the 6 should be. I'm going to go ahead and add an extra part to my table. We call these hidden values. The STAR test loves to use these. The 6 comes down here, and that's the pattern on my y side. On my x side, it's just -2, -1, 0, 1, 2, 3. The next number would be 4. Okay, always write out your table first, and then go over here and see if we can answer the questions. All right, again, just true or false. The equation of, sorry, I started at the wrong spot. True or false, the vertex is 1, 0, and it is the maximum. So I do agree that the vertex is 1, 0. The vertex would be in the middle. It would be at the center right there. Right? It's the only one that does not have a pair attached to it. I agree with that, but I don't agree with the fact that it's a maximum. To figure out if it's a maximum or a minimum based off of your graph, you just simply look at this number and ask yourself, okay, is it bigger or smaller than all these other numbers? So 0 is actually going to be smaller than 2, 4, 6, all of those numbers. So since it's smaller, it is not a maximum, it is a minimum. So this one is false. Next, the question said, the equation of the axis of symmetry is y equals 0. Again, there is an axis of symmetry, but it's not y equals 0. Our axis of symmetry is always x equals. And once we find our vertex, it is the x value of that vertex. So it's x equals 1 in this case. Always the x value. The graph of f of x is going to open upwards. Again, the way that you can tell this is first if you have a maximum or a minimum. Obviously, if you have a minimum, it's going to open upwards. If you have a maximum, it's going to open downwards. That's how you can tell. So since that's my smallest value and all of these are bigger, that means that that graph is increasing as it goes. Since it's increasing, it's going to open upwards, so that one's going to be true. True or false, the vertex is at 1, 0, and it is the minimum. This is the one that we agreed on already. That one's going to be true. The 0.46 is also a graph of this function. So this one is super easy because we've already completed our table. I don't even have to think about it because I did this before they even asked me the question, right? We already connected the 6's, and we even added that 0.46 is part of my equation. That's going to be true. The equation for the axis of symmetry is x equals 1. Again, we've already fixed this, and we've said that it is x equals 1, so we're going to write true. The range of the function is all real numbers. The range is never all real numbers. That is always the domain. Domain is always all real numbers, so this one's going to be false. The range of the function is all real numbers greater than or equal to 0. Again, we can think about this as our minimum. If I were to type this equation into my calculator and I were to look at my table, all of my numbers would be greater than that 0, bigger than that 0, so that one is going to be true. Using the table, what is the value of x whenever f of x is equal to 4? So this is the one where we said if it's on the inside, it's your x value. If the number is on the outside, it's your y value. So what we're basically looking for here is, what are they asking me? Are they asking me to look for my x value or my y value? Again, if we look at this statement here, the number, the 4 itself, is on the outside. Since it's on the outside, it is my y value. So it's asking me what is the y value, what x value has a y value of 4. So what we would do is we would look down our y-axis, our y values. We would look for 4s. We have 2 of them. We have one there and one there. Both of those are connected. The x value on my table that has those, we just look back over this way. X value is going to be 3. X value is going to be -1. So the x value that has 4 is going to be x equals 3 and x equals -1. Right, those are the x values that have a y value of 4. I says which equation is the best fit for the function. Easiest way to do this is just a simple table match. We're going to go on here, we're going to type these in, see which one of these actually gives us the equation. So I'm going to type in 0.5x squared minus x plus 1. It's not really a big secret to this. If I start comparing my table, the one that's given to me to the one that this table gives me, it does not match. So that's not it. Alright, so we clear it, cross that out, go on to the next one. B says 5x squared minus x plus 1. Same thing, doesn't give me the table, so B is out. All this is just process of elimination. Negative 0.5x squared minus x plus 1. That doesn't give it to me either. I think I may have typed in the first one incorrectly, which happens. And then 6x squared plus x plus 2. I don't think that's going to be it. Yeah, that's definitely not it. So I definitely think I typed in the first one incorrectly. Let me double check and type it in again. Whoops, not graph. So none of these really work. Or maybe I typed them all in correctly. Yep, I don't know. It doesn't seem to be working for me. Huh. Well, I guess this might be a typo. All of our equations don't really seem to fit. But that's what you would do. That's how you would solve it, is you would just type it into your calculator one at a time, see which one gives you the correct thing. Alright, let's over to the back. Number 4. How would the graph of the function y equals x squared be affected if the function were changed to y equals x plus 4 squared? Again, easiest way to do this, go to y equals, type them both in. Starting with your original, that's going to go in y1. Your new function, your transformation, is going to go into y2. And then you just simply look at the graph. So if I type this in, we type one into y1, the other one into y2. So we do x plus 4 squared. Alright, we hit graph. There's my original function. there is my new function. We can see that it simply just shifted to the left 4 units. So we would just say shift left 4 units. And of course on your calculator, I'm very particular about this. I'm pretty sure your teachers are. Don't press your pen onto here or pencil, but you can lightly count over 1, 2, 3, 4 units. And on your test, you'll most likely have a multiple choice that says left, right, up, down, something like that. So you should choose the one that says left. Number 5, what is the graph? Use the graph on the right to answer the following. So there's my graph. First question, what is the vertex? My vertex is the center, and it is right there. That point is going to be -1, +16. Is it a maximum or a minimum? It's at the very top, so it's going to be a maximum. What is the axis of symmetry? Again, once we write that equation down, the axis of symmetry is the line that cuts this parabola right down the middle. So it will be that line there. Axis of symmetry is always going to be x equals whatever that number is, whatever it crosses. In this case, it crosses at -1. So my axis of symmetry is going to be x equals -1. It's always x equals. Or if we're writing axis of symmetry, of course, I can write x equals, and I just look at my x value of my vertex, -1. What is the range of my function? Again, we look now at the y values, so this is going to be y. As I look at my y values going up and down, I see that the very top of this is 16, so y, 16, and then all of my y values, my entire graph occurs below the 16, so I'm going to say less than or equal to 16. Next one says, what point is symmetrical to -4, -7? So if I go back 4, up 7, or sorry, -4, +7, if I go there, all I have to do is just come straight across, and that's the point that's symmetrical to it. This is the point that's symmetrical to it. That point would be the point 2, 7. For what x values is the function equal to 12? So whenever it says equal to 12, all you do is just go up to the height of 12, draw the line, and then we just look across. I have 2 places where that line is equal to 12. If I trace this down, it is at -3, and it is at +1. Alright, those 2 values. What are the zeros? Zeros, also known as x-intercepts. So what are my x-intercepts for this equation? Again, all I do is just look at where it crosses, this time my x values, or sorry, my x-axis. I have 2, one at -5, one at +3. And of course, if they want you to write them as points, it would be the point -5, 0, and 3, 0. That's why they're called zeros, because of these numbers right there. All right, next one, number 6. It says, given the function y equals (x minus 2 squared plus 16, tell whether the following statements are true or false. If false, correct the statement with the correct information. Once again, it is very, very difficult, especially for students, Algebra 1 students, to visualize parabolas or visualize the quadratics. Easiest way to do this then is going to be based off of our calculator. So we're going to type this in. Alright, so I type it in. I'm going to go to my table. I can look at my graph, but it doesn't always work out. So I can't see the very tip of this, but you can answer some questions from that. Whatever you can't answer from that, you should be able to answer from your table. Okay. So the first one says the graph has a minimum point. So with that, 2 ways. If I look at my graph, even though I don't see it, I know where the top is. The top is going to be somewhere up here, which if it's at the very top of my graph, it's going to be a maximum, not a minimum. So this one is going to be false. That should say max. I can also do it for my table if I was looking. Once I find where it's the symmetric pairs, right, 15 with 15, 12 with 12, 7 with 7, I would see that my vertex is at 2, 16. And with that, if I look if that's my vertex, then all the other numbers are either bigger or smaller, so all the other numbers are actually smaller than 16. Nothing will ever get anything higher than 16. All right, so that means that 16 is my maximum, not my minimum. All right, the graph opens upwards. Same thing. If it was opening up, then if that's my vertex, all the numbers would be bigger. If it opens down, then all the numbers are smaller. Or, once again, I can just look at the graph and tell it's going to open downwards. So both of these have been false so far. Next, the axis of symmetry is the line x equals 2. So what that means is that if I cut this right down the middle at 2, that would be the middle of my parabola. It's kind of hard to tell off of the graph. But if I go to my table, again, I find my vertex. My vertex, again, we said was going to be 216 because that's where all my symmetric pairs show up. So since it's 216, again, my axis of symmetry is going to be the x value of my vertex, which is x equals 2. So this one is actually going to be true. Last one, one of the x-intercepts of the graph is negative 2, 0. So all I really have to do is just go over to negative 2, 0 and see if that is an x-intercept. Negative 2, 0 is in fact an x-intercept. Of course, I can also do it on my graph. Back 1, back 2, right there, it does cross the x-axis. Since it crosses there, it is going to be a true statement. All right, number 7. An object is thrown upwards from the top of an 80-foot tall building with an initial velocity of 64 feet per second. The height of the object after t seconds is given by the quadratic equation h of t equals negative t squared plus 6t plus 40. Use this function to answer the following question. So we're supposed to tell them the maximum height, how many seconds it takes for the ball to reach the maximum height, and then how many seconds the ball is in the air. So in other words, when does it hit the ground? Okay. First, really you don't need this, really you don't need that. Your whole equation and everything is already given to you with that equation, so that's what we use. And obviously x instead of t. We go in, we type those in, I can hit graph. It may not show it fully, right? So for example, it doesn't show it fully. What I can do is I can adjust my window. I can kind of mess around with my window. You know, if I wanted to see the top of this, it looks like it's at least at an 80-foot tall building, so it might even go up a little bit higher. But we'll see if we can answer these with our table. Okay, so And so it might seem a little wrong, but I think our equation might actually be off. That 40 might actually have to be an 80 for this to be an 80-foot tall building. But we'll just see. We'll go based off of our numbers that we're given and not any speculation that I might have. Okay, so once I find the middle of my parabola, or once I find the middle of my table, right, I have the 40 with the 40, 45 with the 45, 48 with 48, 49 is in the middle, which means that that is my vertex. My vertex is 349. All right, so the first one says, what is the ball's maximum height? And so I would go to my vertex, right? If it was, so this parabola right now, if I hit graph, even though I don't see all of it, I do know that it's going to be a parabola that looks something like that, right? And obviously right now, if we're talking about time, we're talking about that. So really it starts about there. So the point starts there, it gets thrown up, and then it comes back down, okay? So that's what we're looking at. Okay, so my maximum height, again, is going to be my vertex. My vertex is 349, so the maximum height that it reaches in this case is going to be 49. How many seconds does the ball take to reach its maximum height? Again, this is all from my vertex. It took it 3 seconds. Remember that this is height, this is time, so 3 seconds. How many seconds in total was the ball in the air? For us to figure this out, obviously it starts at time of 0. And if that's measuring height, then it's in the air this whole time until the height is 0. Whenever the height is 0, That means that that ball has gone up, hit its maximum height, come all the way back down, and once it hits the ground, then it's done. So what we have to do is we have to measure the x variable and figure out what x value does it actually hit 0 at, and that's when it hits the ground. That's when it stops being in the air, right? So we're just going to scroll down. So 6 seconds it's still in the air, 7 seconds, 8 seconds, 9 seconds. Finally at 10 seconds it has left that person's hand, gone from 40 feet to 45, 48, 49, back down to 48, back down to 45, all the way back down to eventually 0. Once it hits the ground at 0, that's when the object is done being in the air, or the ball is done being in the air. In that case, it was 10 seconds. Okay. Keep going. Number 8. An object is thrown from the top of a 100-foot tall building. The graph representing the situation is shown at the right. Answer each question below about the situation. So there's our graph. And we're just supposed to go through and just answer the questions. I don't have an equation for this. If they do give you an equation for it, then you would just simply go in here, type it in, and then what you would do is you would adjust your window just to make sure that you can see it on your graph. So for example, this window would be 0 to 18, counting by, looks like 2s. My y-axis would be 0 to 20, 0 to 150. Counting by looks like 25s. Alright, and then if I did that and I hit graph, my graph would actually match that graph over there. Okay? So that's how you would adjust your window. Alright, so maximum height of the object was about, so most of this I can actually read without. I can see that the very, very top, the very height of the object is going to be 125. The object was in the air for blank seconds. Again, it starts here, leaves my hand, it goes up, hits its maximum height, comes back down, keeps coming, keeps coming, keeps coming, keeps coming, keeps coming. Eventually it hits the ground. It hits the ground and it stops being in the air at 16 seconds. So in total it was in the air for 16 seconds. Next one, C, the object was at 100 feet for about, this one I would just cut right here. Again, because I'm looking at 100 feet in the air. It actually hits it at 2 points. Right before it leaves your hand, it's already at 100, so that is at time 0. Again, if I follow this down, technically that would be 0. And it goes up, hits its maximum height, comes back down. When it comes back down, it hits 100 feet again, and at that time, it's going to be at time 10. What does the point 10, 100 mean in this situation? Write it in a complete sentence. This just basically means that it comes back down to a height of 100 feet after 10 seconds. Again, it's important for you guys to understand that it comes back down. This is not the first time that it's been at 100 feet. It comes back down. So it starts at 100, it goes up to 125, and then it comes back down to 100 feet after 10 seconds. Right? Again, make sure that you are keeping all of these aligned. So 10 seconds, 10 should be the seconds, height should be in feet. Complete the statement from the graph. Blank depends on blank. And this is basically your independent and dependent variable. Time is never dependent. Time doesn't depend on anything. Everything depends on time. And in this case, if we're looking at our two variables, in this case, height depends on time. So where your object is in the air depends on how much time has actually passed and how much gravity has actually pulled it down. All right, number 9. Given the quadratic function y equals x squared, write a new function to reflect a shift with each vertex given below. Alright, so this is from our equation, y equals a, x minus h, squared, plus k. Alright, so they basically want me to go in and just write a new equation that has these vertexes on there. And I think this word here is kind of misleading. They're not actually asking me to reflect this in any way. They just want me to rewrite the equation so that it looks in vertex form that it looks like this equation here based off of that, so that it'll have a vertex at these points. Really, this is actually pretty simple. Vertex form, your vertex technically is at h comma k. So these vertexes right now are already h comma k, so all I would have to do for the very first one, and for all of these really, is take that 6, negative 6, plug it in there. Take the 8, plug it in here. A value is actually going to stay at 1, so I don't really need my A value. And then I just plug it in, simplify it out, and then I solve, and then I'm done. Right? So something like this would translate into y equals x minus. The x minus is part of the equation, and then the h is its own thing. So x minus, and then the h is negative 6 squared plus 8 in this case. Alright, so the first one would look like that. I can very easily simplify this. Anytime you have minus minus in your equations, you can actually make that into a big plus. If I make that into a big plus, it kind of drops the parentheses. So now this equation is just simply y equals x plus 6 squared plus 8. I can verify this on my calculator. But let me reset my calculator. I can go into x plus 6 squared plus 8. I can go to graph, and I can see that my vertex is in fact 6 over and up 8. I can also verify it on my calculator that it would be 6, 8. Or sorry, negative 6, 8. That's where I'm messing up. Negative 6, 8. That's, again, oh, sorry, I was over there. So there's my vertex at negative 6, 8. Again, I can tell it's my vertex because if I line these up, then 9 goes with 9, 12 goes with 12, 17 goes with 17. My vertex is, in fact, in the middle, in between those at negative 6, positive 8. And really, we would do that with all of these. My second vertex would be y equals x minus 1 squared minus 4. That's my second equation. Third equation, y equals x minus. Remember, x minus is part of your equation. The 6 comes in, squared, and then the 3 is just tacked on at the end. And then last one, vertex at 0, negative 2. This one's just going to be y equals x minus 0 squared minus 2. And technically x minus 0, I can also write that as just simply y equals x squared minus 2. Right, I don't have to, technically the x minus goes away, x minus 0 goes away, I'm left with just x squared. But those are your three equations. Again, you can go through and you can type those in, you can verify them on your graph, that's where they would be. Number 10, write the equation of a function that would appear to be shifted 3 units up from the graph of x squared plus 9. This one I may not be able to show you on my calculator per se because my window wouldn't allow it. Of course, I could go in and change my window. But I just want to show you guys how easy something like this would be. So again, with our equation, y equals a x minus h squared plus k. If they want me to shift this 3 units up, k is the variable responsible for moving this up and down. So k is the thing that I'm going to change about my equation. Nothing else is going to change. So really with this, if I wanted to shift it 3 units up, all I do is x squared, the plus or minus whatever number at the end, that is your k value. So in this case, plus 9 right now is my k value. So right now this equation is so right now this equation is already shifted up 9 units. If I wanted to shift it up 3 more, then all I would have to do is add 1, 2, 3, and it would shift it up another 3. Again, let me make my window a little bit bigger. Let me let my y max be 15. That way you guys can see it a little bit better. So now the maximum height all the way at the very top is 15, right? So right now we're at plus 9. That's plus 9. Basically, to get up 3 more, I would just simply do this plus 3. F of x comes down. X squared comes down. and then 9 plus 3 is going to give me 12. I just simply go through and just add 3 to the 9. Now if I type in that equation, I'm going to leave the original one on there so I can see the transformation, x squared, this time plus 12. If I hit graph, I see that it does in fact, all it does simply does is just shift it up another 3 units. Right, pretty straightforward. All right, number 11, write an equation of a function that would appear to be shifted 4 units to the left of x minus 2, or sorry, x squared. Again, this goes back to our equation y equals a x minus h squared plus k. Let me reset. Alright, so with something like this, again, we would just simply go in and write our equation. A is the thing that's not being changed. They don't ask me to change the shape. They don't ask me to shift this up and down. They're asking me to shift this left and right. So now the question is, what number is going to shift to the left? Your teacher should have told you the I over. Inside your parentheses, it's always going to be opposite of what you think. So if I want to move this 4 units to the left, usually we would think that minus 4 would move it that way. But minus 4, whenever it's inside the parentheses, actually does the opposite thing. It actually moves us to the right. So this minus 4 is not going to work. Plus 4, usually plus, if we're thinking about right and left, positive is usually going to move us to the right. But if it's inside the parentheses, it's actually going to move us to the left. So that's what we want. We want x plus 4 squared. Of course, with anything like this, especially with the ones that are inside the parentheses, my suggestion is always going to be to type these into your calculator. Really, there's no excuse to miss these, especially since you have a calculator, because it really only takes like 10 seconds to type this in, and then you just graph. That's my original. That's my new function. It did, in fact, move to the left 4 units. So I have gone in and done this correctly. So that actually works, and it's verified by my graph. Always verify with your graph. Next one, state the domain and range of the following functions. I'll do just a few of these. I won't do all of them. First one, negative x squared plus 10. So I'll go to my graph. It's a parabola that's upside down. The very, very tip top of this is going to be 10. First, with all of these, my domain, since there is nothing stopping it, my domain for all is going to be all, whoops, too many. It's going to be all real numbers for every single one of these, because there is nothing stopping our parabola. It doesn't have a start point, end point. It goes on forever, right? Even though we don't see the arrows down here, we do know that this goes on forever, this goes on forever. Our domain is going to be all real numbers for every single one of these. All right, really, it's the range that we have to watch out for. So I'll do just the first ones for A, B, C. And it should make sense from there. All right, so I've graphed B, or sorry, I've graphed A. That's A. My range, I always write it as y, and then I look for the maximum or the minimum value. In this case, the very tip top of this is going to be at 10, right? I know that because of the plus 10 right there. So I'm going to write y, I'm going to leave a little bit of space, I'm going to write 10, and then I just simply ask myself, for my y values, all of those going to be bigger than 10 or smaller than 10? You can look at it from your graph. You can tell that all of your numbers are actually below the 10, so they're all going to be smaller. Or if you simply go to your table, right, once we find our vertex, again by connecting, we can see that that's the 10. That means that all of these values, every single y value, doesn't matter how far you go, they're all going to be smaller than that 10. So we write smaller than or equal to, or less than or equal to. Next equation, y equals x squared, negative x squared minus 15. Oops, minus 15. With this one, I'm definitely going to have to change my window. Let me make my x min 0. No. Negative 10 is fine. Let me make my y min 0 and this negative 20. Oh, what did I do? Oh, sorry, this is negative 20. Alright, so I've gone in and I've graphed this. Again, I've changed my window. So the very top of this is 0, the very bottom of this is negative 20. My graph starts at negative 15 and it opens downwards. So again, my range for this would be y. If I go to my table, my smallest number is going to be at, my biggest number is going to be at negative 15. Once again, I find the middle of my equation by doing all my rainbows. The middle of my vertex in this case is going to be 0, negative 15. All the numbers are going to be smaller than the negative 15 because they're all bigger negatives. Remember, the more negative you are, the smaller you are. So all of those numbers are actually smaller, right? They keep decreasing. So y, I'll go back to my graph. Y value, negative 15. All of my numbers are smaller than or equal to that negative 15. And then finally I'll do, I guess I'll do this one. No, I'll skip this one. I mean, you guys kind of get the gist of this. All right, we'll do the last two real quick. Quadratic function f of x equals 2x squared minus plus 4x minus 6 is shown on the graph. What are the zeros? Let me make sure that you guys can see this. All right, so number 13, we'll do this quick. Quadratic function, again, there is typed in. You are more than welcome to type this into your calculator. In fact, I wouldn't advise you guys to. What are the zeros? Since they already give me the graph, I don't really need to type it in. My zeros of my function, also known as my x-intercepts, are going to be there and there. And my 0 is going to be negative 3 and 1. Again, if they want you to write these as points, it's just negative 3, 0, and 1, 0. Again, you can find those on your table. What is the axis of symmetry? To find the axis of symmetry, I have to find my vertex first. My vertex is here at negative 1, negative 8. I would draw my line going through this. That is my axis of symmetry, usually shorthanded as AOS. So my axis of symmetry is the equation x equals, all I have to do is look at that, x equals negative 1. Or x equals, if I had my vertex drawn out, which my vertex is negative 1, negative 8, my axis of symmetry is just the x value of that. For what values of x is the function equal to, negative 6? So again, all this means is at what x values do we equal negative 6? Is my y value equal to negative 6, in other words? All I do is just go down to negative 6, draw a line straight across. And so I actually equal negative 6 at 2 points. All I do is just now trace those back up. That's going to be at x equals negative 2 and at 0. All right, pretty straightforward, the way that we bring those up. All right, last one, 14. John entered 3 functions into his calculator and recorded the values on the table. We're going to see if we can answer the vertexes. So first one, vertex of y2. This is all done with your rainbows, or what we also call symmetric pairs. Negative 5 with negative 5, negative 2 with negative 2. And then even though the 3 doesn't show up, I know that there's another 3 down here. My vertex is always the point in the middle, so in this case it's going to be my y value. Your vertex should always be a point, so that's going to be negative 6. And then across from it we have 0. So you always have to have an x value and a y value. Vertex of y3, again we do the same thing. This time it's negative 8 with negative 8, negative 5 with negative 5, and then once again, even though I don't see the 0, I know that there's a 0 up here. Alright, this time my y value is negative 9, and my x value is the one right across from it, which in this case would be negative 1. Axis of symmetry for y1. So to find my axis of symmetry, I first have to find my vertex. Alright, so vertex of this one, negative 1 with negative 1, 4 with 4, 9 with, even though I don't see it, 9. Alright, so this is my vertex here at 0, 0. My axis of symmetry is going to be the x value of my vertex, which is going to be x equals 0. D, the graph of y2 is shifted blank units from y1. So y2 is shifted, looks like down 6 units, right? And we can figure that out simply by saying, okay, 0 minus 6 gives me negative 6, 1 minus 6 gives me negative 5, 4 minus 6 gives me negative 2, and then 9 minus 6 gives me 3. Right, so again, the common theme here is that all of these are minus 6. These are all of my first values. These are all of these. And if I subtract 6 from all of them, I get all of these. Right, so again, that will just go in there. The common theme is that if I subtract 6, I get these values. So it shifted 6 units down from that. Okay, I hope that this was helpful for you. I hope that you guys do well on your last test, again, right before finals. And I hope you guys are studying, and I hope you guys are working hard. Good luck on your test tomorrow.